Okay, so hi and welcome to the Code Maven meeting. And this is going to be a presentation about the fixtures, writing fixtures in Python, in pytest. My name is Gabor Sabo. I've been teaching programming for more than 25 years, many years Perl, then many years Python, and recently I also started to teach Rust and a couple of other things along the way. And as I mentioned, this is about Python and fixtures. I think I'm going to share the video, the screen, and if I find the button, it's always a challenge, always a challenge built in. Okay, so you're supposed to see now my the website of the meetup. If you're not registered on this meetup group, then please do so. It's called the Code Mavens group, which is my English language group where I'm giving these presentations. And I would like to emphasize that this presentation and the other presentations are free of charge, partially thanks to all the sponsors through GitHub sponsors and Patreon and PayPal. And I would also like to dedicate this presentation as well to the soldiers who are fighting and risking their lives, so my family and I can live in safety and in relative safety and peace one day. Okay, so about PyTest. We had a presentation earlier, and there was a recording earlier that you can see, what you can watch on YouTube, on the YouTube channel of Code Mavens. And if you don't know where it is, so you can go to Code Mavens YouTube. This is the English going to reach the English language channel, so it's the Code Maven channel. There, apparently, I use singular. The groups in Meetup is plural. So here there are the videos, and so go just subscribe to the video, the channel, and you can find the various videos here about Python, and also the testing, the previous video about testing. And this one we are going to talk about fixtures. As earlier, I'm going to primarily use these slides that I prepared up front, that I use also for my training. And I usually also use the excuse to update the slides and maybe to write some more code as we go along. If you're unclear where these slides are, so they are public. They are on the. I share the link in the chat, and I'm going to put it underneath the video, the links. So those who are watching the video can find the slides and the examples. So that's a sort of how can be helpful. So what are fixtures? So I assume that first of all, I assume that you already know how to write tests with pytest because you already watched the video. So now we are talking about fixtures. So what are fixtures? And fixtures in the test community, they have one definition, and in the Python community, or specifically the pytest community, is a slightly extended version of the same thing, basically. So a text fixture, and there is a link, I guess, to the Wikipedia description of it, is basically the environment in which you need to run the test. So, for example, I would like to test some application that needs a database behind it. Then setting up that database is part of the fixture, and then talking to the database is the test. Okay, it's part of the test. And if you have in the next slide, actually, I think I have some more details about it. So this is the general name fixtures is used for setting up some environment and then tearing down or removing it or cleaning up your computer and your environment from it. So for example, if you have to set up a database, then maybe you remove that database at the end, or if you have to create folders, then you remove those folders, and all kind of other things that can be. This is the fixture. In pytest, the same thing, the same word fixtures is used for slightly more generic things, anything related to setting up environment and tearing down environments, that sort of code fixture in the pytest world. Now, here is an example. Oh, and for some reason, this is okay, good. So I just had to update some of the slides. Apparently, I will have to press Ctrl+R in order to update them because they were recently updated and it's still being cached in my browser. So this is the new version of the same slide that we already saw. The first two rows we saw early. And there are the general examples that I wanted to talk about is one of these database sync server. The other one is going further with it, maybe filling the database server with some data. So a specific example would be you have a web application, let's say, where you have allow the users to register and log in and do all kind of stuff. So when you test the login process, then you already assume that you have the database and you already have a user that maybe was already verified, that this is the email was verified, and then you're trying to test the login part. So these are all part of the fixtures, setting up the database, adding the data, and so on. And when you want to run the same test again, then you will have to clean up. Before that, you have to set up it again. And so usually we want to clean up all this information, all these things from the computer, from the database, after we finish running the test. Another example here is, let's say you have a process which is a pipeline of several things. You get some data, you do some processing on it, then you do some more processing on it, and so on. So when you're testing, let's say, the third part of this pipeline, then the fixture would be setting up all the output that you would expect from the second pipeline. So you don't want to, when you're testing the third pipeline, you don't want to run the first and the second and only then the third. You would like to set up the result, the output of the second pipeline, prepare that as the input, as the fixture, as the setup, as the environment for the testing of the third pipeline. So basically, these are a couple of these ideas. And so here is an example of some test where I need to set up a database and then tear down this database. So we are using the setup, and instead of remove, we use the tear down word, because the word tear down, because that's how that's the vocabulary that is used in pytest and in other areas of testing, other languages and other testing. So the tear down is basically the removal of the unsetup, okay, and the cleaning up of everything. So here we have three tests, okay, test 1, test 2, test 3. Not very interesting in that, but for each one of them we have to have a database server, and we have to set up a database in the database server with, let's say, some data. But just for this now. So the naive way to do this is that for every test function, we call the setup database server and then the setup DB, and at the end of every and at the end of them, we call the teardown database and probably also the teardown database server. I don't know why I put it commented out. Actually, I know. I'll explain it in a bit. So basically, for each function, we have to add all these calls that will set up at the end tear down the system. Now, here what I was trying to show is that we have the setup database server, which we only need to run, or theoretically, we only need to run once for all these tests. And the setup DB, we might want to run for each one of these tests separately, because this is setting up a server, okay? And this one is setting up a specific database for that test inside the server. So we don't need to set up the server again and again. Or we don't want to, because that's just wasting time and CPU. So I had some code here. It's not very interesting. What it basically, the setup DB server is trying to cache the information that there was already a database server set up. And so when I call the setup database server again, it will already return the original data, the address of the original database. So I still need to call it every time, but it will only happen once. I have the problem of the teardown. I think I put it here. then it somehow needs to be able to count or know that this is the last test that is being called, but how can it know it? So it's a problem already how to tear down this. But there is an even bigger problem. As you can see, these tests, so this one is faking the fact that it's successful, and this test is faking the fact that the test itself would fail. Now, the way pytest works is basically it has these assertions, and then if one of the assertions fails, then the assertion raises an exception, which means that the specific test function stops running. It raises the exception. And pytest, because pytest is running the test, pytest captures that exception, and then it can collects the data. But this means that if there was an exception here, then the rest of the code, so the teardown pound, won't run in this case. And this is a problem because we were relying on the fact that there is a teardown function at the end of each test function. So now we have a problem that we have to count how many times the database server was tore down, okay, and which one is the last one, so we don't remove the database server prematurely. And we also have to deal with the fact that some tests won't actually reach the end of the code, so the teardown of the specific database won't work. So there are two ways to use the fixture environment, let's say, or fixture services of pytest. There are two major ways. One of them is what we call the XUnit style, which is the older style, which was used in Java and I think C# and some of other languages. And I'm going to explain this style. This is the older style. You can still use that, of course, but there is another, a newer and probably much more powerful style provided by pytest. So in this style, the XUnit style, allows us to create 4 functions. The setup module function, teardown module function, the setup module, the teardown module, the setup function, and teardown function. Okay, let's not repeat the word function again. Okay, what do they? You don't have to implement any of them, as we saw earlier, and you can implement only some of them if you like. What will happen is that if you have a setup module, then this function will be called once for this whole test file. And if you have a teardown module, it will be called once for this whole test file after all the tests ran. On the other hand, the setup function and teardown function, these functions will be called before and after each test function, which is also interesting because, you know, if we run this test file, pytest will execute all the 3 tests, but we don't have to. We can run and decide to run only one of the tests or some of the tests. pytest allows us. And still, this will run before any of the tests run, and the teardown module will run after all the tests are done in this file, and the setup function will run before each test function and the teardown after each test function. So we have wrappers around each one of them, and also pytest makes sure that the teardown functions always get executed. So even this teardown function, the teardown function, okay, gets executed even if the test fails, like this one. In the next slide, we can actually see the order of the execution, and I think I need to update here as well. So I was trying to show here, and actually I can even, yeah, we can see it here. So the first thing, the setup module will run first, and the teardown module will run last, so these functions, and they run only once. And then the setup function will run before the test. This is one after the end of the test one. And this is the teardown function that runs after each test. So here again, setup function, the test 2 starts, it raises an exception, so it doesn't finish, but the teardown function runs again. And same again, third time, setup, teardown, and then the test 3 was in the middle. So this, we can see the hierarchy. Now this, what you can see is that the setup module setup, well, it's not a database, it's just a temporary folder, but it helps understand it. So the setup module created one, and then we are reusing the same one all the time, which is what we wanted. Okay, so we have one which is fixed for the whole module, and then for each test function we created a separate one, which you can see these 3 are for the test 1, and then these 3 are for or these 2 3, I guess, yeah, are for test 2, and these 3 are for the test 3. So each one so we have a shared one, which is from the setup module till the teardown module, and we have each test has its own environment. Okay, so this is the XUnit style for tests which have test functions. But we have, as you can see, we have a problem here. Okay, I haven't even emphasized it. Went back. We have a problem that how can we pass the database that, sorry, this is the code. Okay, how can we pass? So we called generated this DB server, which actually just a temporary folder now. But how can we pass this DB server to the actually test? How can the test access that one, or how can the test access the DB that was created in the setup function? And I think the only way in Python, well, the relatively easy way in Python, and it's not very good way, but it's an easy way, is to create global variables and then assign to these global variables, and then all the others will be able to access it. Now, this is not very nice, but other solutions wouldn't be too nice either. Okay, but this is what works. So there is other way to do this, and this is in case you are using class-based tests. So you can write also test pytest by defining a test class or test something. It doesn't mean the word doesn't need to be class here. Just test something, and then inside you can have the test methods basically. So the same idea is the test functions, but here the test methods. And here you can have setup class and teardown class methods, and setup method and teardown method. So same as for the modules, slightly different names, because now we are in a class environment. And here we can solve most of those problems that we encountered in the previous one. Sorry, I'm just jumping too much. So in the previous one with these global variables, that problem can be solved relatively easily here, because we have an instance of this test that is passed to each test method. So we can access the value from there. And I don't have it written exactly, but the same way as the teardown can access the value, the same way the methods could also access them. So that would help solving us the global problem. And here is the output for the same thing, same idea. I don't have the addresses of the test classes written here. But anyway, we are going to the other style, which is going to use dependency injections. By the way, if you have any questions, feel free to ask, either just opening your mic, if you don't mind that your voice is being recorded and published on YouTube, or just type in your address in your question, sorry, in the chat room. So what is the dependency injection? Is a style of programming where you basically define a function and you set up some parameters for the function, but it's not you that you are actually calling the function. Just as with the pytest, right? The pytest, we don't ourselves call the test functions. We just created the test functions and then let pytest call those test functions. Now with dependency injections, what also happens is that the caller, okay, in this case pytest, will see that, oh, you're expecting in this case, pasta and sauce. So let's prepare some pasta and some sauce and pass in to this function. Okay. So instead of me, the programmer, worrying about calling this function with pasta and sauce, it's now up to pytest, the caller, to prepare these values for these variables and call the function and inject the dependencies, okay, the data into these functions. Now, obviously, pytest needs to know how to prepare pasta and how to prepare sauce, okay, and that's what we are going to see in the next few slides. How can we implement this with pytest? And then inside this test function, or inside this, this same style, this dependency injection, is not just for pytest. Other environments can do the same. But this is basically what they do. If they find a function, the environments find a function that they want to call, they check what parameters the function is expecting, prepare the appropriate data or objects or whatever based on their internal knowledge of how to prepare pasta and sauce, okay, in this case, and then call the function with those parameters. That's basically the dependency injection, or at least that's how it's used in this context. Maybe it's in other contexts, the same word or the same phrase, the same name, dependency injections means something different. And let me take now, well, I have to get used to this. So let me take a break and just remind everyone that we have a YouTube channel called Code Maven. And so if you're watching the video on the YouTube, then please like the video and follow the channel with this bell. Great. I have to remember to keep saying this in the videos, even though it's live presentation. Anyway, so let's see the first such dependency injection in with pytest. And this one actually we don't have to prepare because there are a few of these dependencies of fixtures that pytest already knows about and provides. One of them is called tmpdir. So if we, in our test, we need a temporary directory, what we can do is we can write in the test that we are expecting a tmpdir, a temporary directory. And then before pytest runs this test, it will create a temporary directory and then pass in the path to this directory into this parameter, and then we can use it. Okay, it's actually a path object actually, but that's the basic idea. Okay, so here it will create us a temporary folder. Now let's try to run this because let me get here. So I can run this one is test tmpdir, pytest and pytest and code test tmpdir. Now I'm explicitly saying what is the name of the test file because I don't want pytest to find all the test files as would be normally the case in a test environment. So I'm running this one, and of course it can't find pytest because I have to start on our virtual environment. Okay, and now it will be happier. Okay, so now it ran and it did something. How can I know where is this folder? So if you look at the example, the first thing I do, I print out the temporary directory. Now, normally it shouldn't interest me, right? Because this one will create a temporary directory, then I do some test with it, and at the end it will hopefully remove the folder. Now, it's not exactly will remove it, and I'll explain in a second. But sometimes I am interested where is this temporary directory. For example, if my test fails, I would like to see what was created in that temporary directory. So that's why I'm printing it out. And if I pass in the -s flag, then pytest will also let through all the printing statements to the standard output. So earlier we couldn't see it because by default the pytest hides all the output. But if I provide a -s flag, then it prints it out. So this is the folder where it was created. Now let me run it again so we can see the other one. The difference is now this is pytest 19. Okay, so it every run, it will create a new folder, and in that folder, it will create basically a subfolder for this test. And if I try to ls now on this one, so there is this subdir that I created. If you go back to the source code, you can see that that's what we did. We created a subdirectory and the file and whatnot. So it's there. And if I go a little bit back here, you will see that actually it kept the 3 most recent executions of my test. So the last one was the 19, the previous one was the 18. Apparently I had the 17 a little bit earlier. Yeah, but the one that I ran without the -s. So these are the 3. And if I run it again, now it will use the folder with number 20. And if I run ls, you will see that it will remove the folder 17. So on one hand, it does clean up after itself, which is a good thing because I don't want to keep around all this data. On the other hand, it keeps the 3 most recent versions of it. And it can be quite useful because after the test finished, we might, especially if something failed, we might want to look at the temporary folder and see what happened there. And as far as I remember, you can actually configure how many of these folders you would like to keep around. The default is 3. So this is a new nice thing, but this is basically how we, this is the first fixture that we used in this test. Any questions, just feel free to ask in the chat room. That's the advantage of being around while I'm doing the presentation instead of watching just the YouTube video. Okay, so here is another example using the tempdir thing. It's basically, it's a very simple program that what it does, it can, these are these config files that look like INI files. And this program, it has 2 functions. One of it is parsing the file, so gets the file name and returns the data. It reads the file, actually, it would be better. And the other one is save the file, so it gets the name of the file and the data, and it saves it. And the question, how can we test this? So in order to test the parse file part, that's relatively easy because I can prepare a few of these data files, include it in my distribution or include it in my Git repository, and then in the test, I would call the parse file with the appropriate file, read it into the memory, and then compare it to something that I am expecting. That's easy. How can I test the save file part? I can, every time I need to provide the name of a file. Now, if I provide the name of the file in the current local directory, okay, sync, yes, no. So here's the test parse, which gets some config file that was part of the Git repository and checks whether the data is as I expected. Fine. When writing, if I used a file in the current folder, that would mean that if I have 2 tests, let's say 2 test functions, and I would try to run them in parallel, then they might collide because both of them using the same file. And also, this would be creating a file on every test run in the local folder. And then should we keep it around that file or should we remove it? It's much cleaner. And also, what happens if let's say, my test function creates so the first time I run it, it creates a file, and then I compare and everything is fine. And then someone ruins the save file and stops actually the saving, but the earlier resulting file is still in my folder. So the next time I run this test, it will think that it created. It will think that it saved the file, but it didn't. But then when I'm comparing the result, it will say, "Oh, it's fine because there was a leftover file from a previous run." So it's much better if we have a clean folder where we can write the files. And for that, this tmpdir can be really nice because it will create a temporary folder, which is empty, and then I can save the file in that folder under whatever name I like. And for each test function, I will have a separate temporary folder. So I won't need to worry that they collide, these file names, even if I use the exact same file name in every test. Good. Okay. So this one of them. Then there's another basically the same idea. I think I don't need this example. This is basically the same idea, right? I think so. Yeah. Let me just check it. Yeah, it's using a file called store.json. Okay, so it's not exactly the same. Let me explain why. So the reason it's not exactly the same here, the application actually has a hard-coded file name. So it knows exactly how the file is called, and it computes the location, the path of the file, based on the location of the executable of the Python program. So I don't have a choice here. So the solution is, unfortunately, means that we have to change our source code in order to make it easier to test. And this is something that there is some level of, there's a question, okay? How much should you change your code in order to make it testable? Okay, if you write from upfront, from the beginning, you always write in the TDD style, so test-driven development. So it's always writing tests, even if you don't write the test before, but immediately after you wrote the code, then very soon, right at the beginning, you will prepare all your program to make it easy to test. If you're coming in late, so you have all the application already ready, and now you have to add the tests, then you might need to have the power or the flexibility, or I don't know what to call it, to make some changes, adjustments to the code to make it easier to test, because otherwise you are a problem. So what I did here is I made a slight change, and I said, okay, get from the environment a variable called store dir, and if it's there, and if it's not there, then fall back to the default that we had earlier, okay? So this is the change to the code, that now it accepts an environment variable to run the code. And now I can, in the test, I can set up this environment variable, and the code will look at that environment variable and use that instead of the hard-coded path. And so this works. Actually, I think this won't really work if you would like to run things in parallel. For that, we probably need a better solution. But at least this way, we can already run the tests, even if I need to run them linearly, several tests, one after the other. Okay, so this is a sort of a trade-off. Let me check. Yeah, that's yeah, okay. So that's the same. Okay, so let's see a different thing, a different problem. Here we have an application that very simple one. The whole thing, there is a function which will print a text. It will get some text, and then it will print either to the standard output or to the standard error. So it's basically a simplified version of the print function of Python. How can and this is the way we can use it. Okay, so we would import it, and then we can call it with some text, or we can oh, sorry, this will go to the standard output, and this will go to the standard error. Okay, whatever. So how can we test it? Okay, we need to capture somehow the standard output and the standard error of our own code. Now, if this was some external program, then we could run it and capture the standard output and standard error relatively easily. But if we want to run it in our process, that will be slightly difficult. Actually, it won't, because pytest provides us with the tools. So we can have this other fixture called capsys, which is different because we don't use this. Well, actually, we do use. Okay, I stand correct. We do use the capsys. So what we have here is this fixture which tells pytest to capture the output and allow me to extract the output from CAPSYS. So here, when I have this CAPSYS, from that point on, whatever is printed to the screen, it's being captured by this CAPSYS. And for example, we call welcome with hello and world. And then we can use CAPSYS read out and ERR. This is basically the name, read out ERR. And it will return us two values, the output and the error that was captured since this started till this point. So now we can check whether the output is really hello and the standard error is really world. The capital letter text is actually coming from the application, so make it easier for us to demonstrate this basically. Okay, so this is how the CAPSYS works. And then once it's captured, I can compare it, and then it starts again capturing. So if I call welcome now, then it will capture from 0 basically. So now the output is just the word next, well, with the standard output, and the error is empty. Okay, so that's CAPSYS, another of these fixtures that you can use with pytest. Okay, there are a few more, but eventually you would want to write your own fixtures. And for that, pytest allows you to define basically any function and then put the decorated by this pytest fixture, and then it becomes a fixture. So let's see how they work. The first one, what you see, is creating a fixture, basically replacing the XUnit style that we had earlier. So instead of using the XUnit style, you can create your own functions and mark them accordingly. And here it is what you do. You create a function, let's say fix module, whatever, okay? You decorate it with this @pytest fixture, and you tell it that it's auto use. We'll see in a second or a few slides what other options are there. So auto use true, by default is full. And you also tell it the scope. So basically this replaces the setup module function. This behaves, not replaces. This behaves exactly as the setup module. This function, this fix module, will be called once before before any of the tests run in the module. Now, this is not exactly true because this also has this yield in here. So basically what we say is that this part before the yield will run before any test runs, and this part will become the teardown module part. So this part will be executed after after all the tests in the module were executed. That way, we actually solved the problem we had. You might remember we had this problem of using the global variables. We don't have this problem between the setup and the teardown anymore because this is the same function. Okay, so if we set up something in we created a variable in the setup part, we can use it in the teardown part as well. And the same way we can create alternatives for the setup function and teardown function by defining something, okay, any name of function, doesn't matter, but we need to decorate it with, again, fixture, auto use true, but this time the scope is function. Okay, so this way we can replace basically the way it was working. Well, you will be able to find a recording here on the YouTube channel. So someone asking maybe came later. So it's a good opportunity again to show you the YouTube channel. I can also even put the link here. Okay. I will also announce the video on once it's ready on the meetup page. But this is the channel where I'm going to publish it. So just follow the channel if you haven't done it yet. Okay, so back to the material. So this is the way basically that we can implement any name of any function name, any function, and then we can create these wrappers just like the XUnit style. Fine, but maybe this is not the really what you wanted. What you may be more interested is still in the next slide. So where it is? Yeah, so the dependency injection. And I'm going to get there, but there was a slide in the middle that I need to explain. I would like to explain is what can you do? And I got back here. What can you do with these functions first? So now we created these functions which are in this file. But what if we would like to reuse this very same fixtures in more than one test file? How can we do this? And that's quite easy, because we can create a file called pytest. This is sort of hard-coded name of pytest. So we create this in the test folder, basically we can create it, or in the root of your project. And pytest will read it and import it without you telling anything. So you basically moved all the definitions of all of my fixtures. Why do I have 3 here? I have 3 here. Okay. Oh, I even have a session level that I didn't have earlier. So we have the function module and even a session level here. And then I can use it in several of the, I don't need to use it, okay? That's the whole point. I don't need to do anything with the test files. They receive that and they are going to use those fixtures, okay? So pytest, that's the magic file name. Okay, now let's get to the most interesting part of this whole thing, is the manual fixtures, or what I call manual fixtures, basically dependency injections. How can we create a function that will be used as a dependency injection? So here it is a function, here's a function called blue, and I marked it as fixture. Now, as opposed to earlier, let me get back to a second. Earlier we had autosave, sorry, auto use true, and we had some scope. Sorry, I have to drink a little bit. So earlier we had this auto use true and scope, some scope. That's when we are creating the XUnit style. When you are preparing for dependency injection, then we don't need to set the auto use because it defaults to false, and that's what we want. So we don't want it to be automatically used, the fixture, and we don't have a scope because it's used whenever you use it, it's being used basically. So that's not really relevant. So here I just marked it as a fixture, and what we have here so far is that we print out blue and setup and tear down. So we said print out setup and then yield and then tear down. And I did it with the same with green, okay? And then in the tests, we can tell the test that it's expecting a blue and a green. And the test 2 is expecting a green and a blue, okay? And then if you run these tests, you will see that there's the blue setup, okay? And then the green setup, and then the test 1 happens, okay? And then the green tear down and the blue tear down. So basically what happens, and this happens before the test runs, this happens before the test runs, and after the test finishes, then runs this, and then afterward this one. So it's the opposite order. And in the second example, we see basically the same with the different that this one is going to fail actually, this test. Okay, because I said assert fail, false, so it will fail. As if it was normally just failing one of your tests. And you can still see that these the teardown functions are, or the parts of the teardown are still called. Why? Because pytest captured that exception and ran the teardown part after the test finished with failure. So that's really nice. This way we can do basically anything before the test and then do after anything. But so far, this blue and green was only there in the signature of the function. it didn't have any value, didn't get any value. And I think that's going to be the next slide. Yes, when the fixture is actually providing some value. So here we have a fixture that sets up some application and then returns that application. So for now it returns, because we are more familiar with the return function. And here is the application, doesn't really matter what it is. In the test, what we can do is we say that we are depending on this up fixture. This is the up fixture. Okay, so we provide the name of the function. And then inside we can use the up object, which is this one. And for each run, for each test function, when pytest is, before it starts running it, it will call this function, which will print up starts. It will create the call the application up, get this object, and return it. And that return will get into this variable, and then we can use it. Now, this is the setup part. It doesn't have a teardown yet, okay? But I thought it will be easier to first use the return, because we are more used to the return. We can also do the same with this yield, okay? So if we have this code, that the same code, okay, sets up the application, and then instead of returning, it yields the application. What happens in this case is that in the test, when the test is running and depends on this myapp this time it's called myapp for some reason, okay, it depends on that one, I guess because here I used the name up. So it depends on it. It will call, pytest will call this function, which will print this one, generate the application, and yield the application, basically assigning it to this variable. Then the test will run. This assertion will run. And then once the test finished, and regardless if it's finished successfully or with a failure, with an exception, regardless of that, then after the test, this part runs. So this is the teardown part of this dependency injection. So basically what you can do is you can set up some application here, prepare something, and then this will return it basically, or yield stop running, okay? But put itself aside, and then the test function will run, and when the test function runs, then we can do the cleanup or teardown if we are using the same wording as pytest does. Okay, so yeah, well, then we just created a fixture, which is okay. My chair was, I almost fell off my chair. Good. We created a fixture that was called before and called after, and returned some value or assigned some value into this parameter. So this way, basically, you can do anything already now. Let's see a couple of these. Let me check. Okay, so this is another application, which is actually very okay. That's not very interesting. This is just using the tempdir test case. The reason it might be interesting is because I have this whole code that I'm repeating every time. So this, I think, in this and a couple of next slides, I'm trying to show you the process that you might do in order to make your tests simpler. So here I'm already using the tempdir fixture, but inside I have the very same code, I think, in both cases, okay, in both tests. And then I think I also have this part is the same, okay? But we can improve this by, first of all, by moving this, the first part and the read file part into external functions. So now the tests are much more simple because we are using the setup config here and here, and the read file here and here, okay? So this would be the first step, trying to, well, that's just normal programming, right? Just moving repeated code into functions. nothing, that's not really special. That would be, you would do the same with your regular code. Just now we are doing this with tests. The next step is what might be interesting is when we convert, is it here? When we convert it, the out file and the read file, okay, I don't know, yeah, we convert these two, those two functions into fixtures. And so in the test, we are not asking for TMP dir anymore. We are already asking for this output file, which is our fixture, and our fixture is asking for the TMP dir. Okay, so earlier, if we go back one slide, we asked for the TMP dir because then we needed, you had this setup config function which would use the TMP dir in order to create some output folder and so on. We don't need it anymore there because now this fixture uses the temp dir and it will return the file where the output has to go. And so now our tests are even simpler. So basically we took 2 steps from very repeated code into fixtures. Okay, this is another test example. Basically, in some application, I was using Docker in order to test. And I think the basic thing is here. Where is it? I think it's in the next slide. That's the interesting part where we... okay, that's not that interesting. We are using the setup module and teardown module here in order to create the definition of how we run the Docker. So we need a folder and run the Docker with that one. Okay, this is the interesting one. I think when we are creating, we have two fixtures. Okay, one of them is this module level fixture, which is auto use, so it will be called automatically. We don't have to inject it into any functions. And the other one is called my port, that is using this image apparently, so it depends on that image, and then in this my port it gets a port number, okay, and we use that port number so we can run in parallel, I guess, in several tests in different ports, and those are the ports that we supply also for the Docker. Yeah, I think that's it, basically. The next one is, well, it's an example. We can use this as an example. Let me just check. Okay, so this was just a repeated slide, not that interesting. This was an example where I used, I had a MongoDB database. So for every test, I had this fixture. So I had this fixture that would create a database and set up an environment variable with the name of the database. And so the tests will be able to access that database, which was just based on the current time. So each test will use its own database inside them, not the MongoDB, not the application database, but inside MongoDB there are these databases. Okay, and after the yield, it will just drop that database. So I even clean it up. I won't have in the MongoDB server too many databases or any, basically. And that's just an example. The pytest with parameters actually doesn't belong here, but we have then a fixture with the parameters. So if you have a test, let's say this one, myMess add, and you are doing calling this add function, giving it 2 values, and are expecting some result. Now, this would be the way to write 2 tests. Okay, so this was with the diff function, doesn't really matter. And I have 2 test cases. Unfortunately, they are both in the test diff function. So if the first fails, then the second won't run, and that's not really good. Better would be to, for each one of these cases, to have their own test div1, test div2 functions. But what if you have 10 of these? Then for each one of them, you create a new function? Well, no. Instead of that, we can use the parameterization of pytest. So basically, what we say is that before the test function, we say that pytest mark parameterize. Then we create a string in which we say that which are the parameters. It's slightly strange that it's a string, but basically we are saying that we are going to have 3 parameters, A, B, and result. And then in a list, we can have the triplets for these 3 variables. So this setup, this parameterization, will run the test add function twice. First with these 3 numbers, and second time with these 3 numbers. And those test runs will be separated, okay? As if we had separate test add functions for each one of the test cases. So I think actually the test, I need to, it would be even better if I changed slightly this example. So the best, let's start it with this, that we have this test add, and before that we would have test add 1, which would get 2, 3, and so it would have like, no, here not 2, 3, and expect to be 5, okay, without parameters here. And this would be test add 1, and we would have another one which is called test add 2, very boring, right? And here we get -1 and 1 and 0, okay? So we could write tests this way. Each test, let me do another one here, okay? And then we have the whole story, test add all, okay? So the story would be that way. Okay, we can write a test for mass add with 1 test function and then 2 assertions. The problem is this, that if the first assertion fails, or 10 assertions, right? If the first fails, then the rest won't run, and we won't know what happens to them. First solution, separating them into test functions. Okay, then each one runs independently, and each one can report independently if it's successful or failure. Fine, but that means a lot of repetition, and I have to come up with these numbers and names. And the best solution would be to have this parameterization where we say, okay, the test for each test case, we need 3 values, the 2 input values for the add and the expected result. So we set up a parameterization, which we say, okay, we are going to have A, B, and result. And then we create a list of the triplets that needs to be assigned to these. So here we have the 235 or the -110. And then pytest will actually call them as if they were separate functions, like in the second case. So they will be independent. Okay, good. This will be the slide will be updated with this one after the video. Actually, if you click here in the slides, you will get to the Git repository on GitHub of all the slides. So in case you would like to clone it or copy paste from there, it's easier than from the slides. And that's I'm going to push it out, and then the slides will be updated as well. So this was the parameterization, and it's not really directly connected to the fixture, but now we are doing this the same with the fixtures. So here we have the parameterization, and we have a fixture, and what we can see that the fixture also gets the parameter. So this parameterization has only a single parameter and only a single test case, not very interesting, unlike earlier. probably I have to improve this, so it will be easier, nicer to have more of them, clearer that we have more values. Okay, so we have one and one here, and it's using the name from here. But we also have this fixture, which is an auto-use fixture in the scope function, and it gets the name parameter. And here it is, we are expecting the name parameter, and we can use it. So this way, it's not just the test function that gets the parameters, but also the fixture will be able to see that parameter, which is nice. And so, yes, so this one was an auto-use fixture. The next slide does the same with a manual use, or what we also call dependency injection fixture. And here too, we tell it that it gets a parameter called name, and it will accept that name. And I think you can, in the output, you can see that that will receive this parameter, actually, regardless whether we here inside the function are using that name. So in the first example, we asked, we set up the parameterization, and we used the parameter, and we had the generate. In the second one, we only had the generate. And that's what got the parameter. But it's fine. And so that's it, I think. And there's another slide with the Docker, but it's not really interesting anymore. Any questions before we finish the video? And just remind you, there is the YouTube video, so the YouTube channel, so please go there and follow the channel and sign up to the meetup group called Code Mavens. Any questions? If there are no questions now in the video, then I'll stop it. And then those people who are around and watching this presentation live, you can stay around and ask some more questions. So thank you very much for being here and watching, and see you next time.